Hello. In this session, we will talk about LaTeX, or rather how to write academic reports using LaTeX, because that's what it's for. So let's dive into it. We'll start with some history, and then we'll get into how to actually write the documents and use the tools. So LaTeX, and particularly TeX, which is what it's based on. TeX was created by Donald Knuth at Stanford University at the end of the 1970s. And he wanted to typeset his book that he wrote at that time, The Art of Computer Programming. He wanted it to be more beautifully typeset because this was a time where the publishers changed to digital printing. And the first copy of The Art of Computer Programming was not to his satisfaction in the terms of typesetting. It was rather ugly. So, but then he figured that, well, these are digital printers, so it's just programming, and that I know. So he decided to start writing a program that would typeset his books for him so they would look more beautiful. So he wrote several programs. So he wrote TeX, and he also wrote Metafont, which was a font system that he used. And so he designed his own fonts as well to use with TeX. And it took quite some time for him to write TeX, but eventually he did, and he typeset his book, well, one of the books, because he's still revising and continuing writing The Art of Computer Programming. So the current version, well, one of the books came out in '97. That's the reference in this slide, and he is continually revising it, and he hasn't actually finished everything he wanted to put into these books. So we'll see how it will go. So this was end of 70s, so starting 80s. And in 1985, Leslie Lamport, he wrote LaTeX, which is basically a set of libraries written using TeX to make it easier to typeset different types of documents. Because in TeX you can do basically anything, and LaTeX is more streamlined towards different types of documents and reports and even slides. So the slides that I'm using in this presentation, they are written in LaTeX. And this is what we will dive into. But basically, you can do anything with these tools, from doing maps to writing notes for music. And another funny thing you could do with TeX is to have the margin being perfectly circular like this, and you can do other things like, for instance, typeset Tolkien's Tengwar language. So you can do basically anything with TeX. So you can check out the TeX showcase for numerous other examples of what you can do. But let's dive into it and see how we do things. So let's start with the document structure, because one difference compared to word processors is that this is not a what you see is what you get system. So you actually type code and then you typeset it and then you get something that a reader would read. So it all works like this. You have some file named, in this example, name.tex. So it always uses the .tex extension for these files. And then the content is code that looks like this. So we set the author, for instance, and the title and the date. And we have some settings. So we want this to be an article. So that's the document class. That one specifies what type of document this should be. So it can be an article, it can be a book, it can be slides. So there are a variety of document classes ready to use. And then we have some packages that set up how to handle everything. So for instance, I use UTF-8 encoding since I'm on a Unix-like system where this is the default. So all the input in the entire document is UTF-8 encoded. And since I occasionally use Swedish, I want the T1 font encoding so that Å will actually be Å when someone copy pastes from the PDF and not being an O with 2 dots over it. So basically, you will always need these two if you work in European languages, essentially. And then you have the bubble package, which translates various things for us. So usually I use English and Swedish, and the last one is the default. Which means auto-generated titles. So for instance, the table of contents will be called innehållsförteckning if Swedish is the default language. But if you set English as the default language, it will say table of contents. So this is what the bubble package does. It also does a few other things, but those are sufficient to mention. And then we specify some data that is relevant for the document. And then comes the actual document. So this is the content, and this part up here, so before the begin document, that is called the preamble. So important to learn that terminology, because a lot of times people refer to the preamble. So remember that word. And in the document, you can write some things. So here you actually write the contents of the document. In this particular example, we just have the make title command, which produces a front page. And then we have the table of contents command, which produces a table of contents. And then the only other content we have is this dots command, which just produces 3 dots. So that's all this does. So let's see how to actually use this code and make a document out of it. So let's bring up the virtual machine and bring up a terminal. So to use LaTeX, you need to install it first, and that depends on what system you're using. But we will use TeX on this Ubuntu system that I'm illustrating this on. So we're in our home folder, and let's create a new document. So we can go to the documents folder, and we see we have a document here, but we want to create an example document. So we go in here and let's name it example.tech. So let's start the editor and start writing. So we start with the document class. We want A4 paper because we are in Sweden. And we want an article because most of the time you will want an article. We'll get back to other types of document classes later. And as I said, I use the UTF encoding. So this basically matters only when you use Å or any other type of non-American letter. And it's the input encoding package that handles this. And the next package, as I said, is the font encoding package. And in this case, we will just write everything in English so we can skip the bubble package. But the author is me, and the title is example document. And the date is optional. We don't have to fill it. If we don't fill it, it will supply today's date anyway. We can do that just to be clear. And then comes the main document. So begin and end document. You should always make sure to get the end part as well. And then we can put in the make title and the table of contents like that. And then we can put these dots here as well. Okay, so now we've written exactly what was on the slides. So let's save and exit. And to make this a PDF, which is what we want to do, we type PDF LaTeX followed by the file name, and then we hit enter. And already we run into an error because I made a typo, but that's good. So we see what happens when we type something wrongly. So the thing it's complaining about is that the begin document ended by end. That's obviously wrong. So let's exit and let's edit the document again. And we see here, indeed, it says end. So let's write end document and save. Now we can run PDF LaTeX again and hope that it's correct this time. Yes, no error messages. So it's correct. And the output is in example.pdf. So now we need to open this PDF with a PDF viewer. And there are various ways to do this. Either you use a file, the graphical file manager, or you simply use whatever is on your system. So I use Evin's because that's the one I'm used to and it's default on Ubuntu. So I'm going to open it like this, and we see we have an example document. That's the title. It's my name and then the date. We have table of contents, which doesn't contain particularly much because there is basically no content. And then we have these 3 dots here. So let's see if we can make this one a bit larger so you can see better. So, but let's close it. So there is one way we can open this one without blocking our terminal, and that is to add this ampersand at the end. Because if we, without it, we see that if we go back to the terminal, it is blocked. We can't do anything here. And nothing will happen until we actually close this window, and then that input will get to the terminal. It will get interpreted by the terminal, and it was gibberish in this case, so nothing to run. Except there is apparently a package actually named slsh, but we don't want to run that. But if we add an ampersand at the end here, then we execute this command in the background. So we can actually continue typing in the terminal. So we saw here that we actually got our prompt back. So now we can have this PDF in the background while we continue working in the terminal. So that's really useful. Let's continue and see what else we can do with LaTeX. So let's get into the main contents. So starting with paragraphs and sectioning. So paragraphs are written as normal text, and each paragraph is separated by an empty line. So something along these lines, that's what we do. So let's try it in our example document. So let's replace these dots with something. So this is a paragraph. This is another paragraph. Save and exit, and then PDF LaTeX and example.tex. Let's recompile. And now we saw that the PDF actually updated in the background. So it says here, now instead of those dots, we have this is a paragraph, this is another paragraph. And we see that there's not much space between them, although we had space between them in our file here. And that's because LaTeX typesets paragraphs as specified by the document class article here. So this the paragraph separation that it uses is indentation. So if we just add more text, so let's add some gibberish text here just to make something that spans several lines like that. Okay, save and exit, and let's recompile and see what happens. So now we see that it's actually spanning longer than one line, and we see that the next paragraph is indented, just like in a lot of books, for instance. They usually use this type of paragraph separation. So what else can we do in this document? So sectioning, usually we'd like to have sections in our documents to separate, to divide the document into nice parts. So let's have a look at, let's have a try at sectioning. So we see here that the chapter type of section, that one is available only in the bigger classes like book and report. So you will likely use that kind of class for like your thesis or XJobs report when it's time to do that. But for most hand-ins, you will use something like article, and then it's these smaller type of sectionings that are available. And we're working in the article now, so we will use some of these. Okay, so let's switch back to the document and add some sectioning. So we do that by simply writing section, and then it's followed by the actual section title. So let's call this one introduction, because they are always called introduction, the first section in a book or document or report or something. And let's save and recompile it, see what happens. So now we see that we have a section called introduction, and it's the first section. It's numbered automatically, which is very nice. So we don't have to care about numbering. It will update automatically. So if we go in and add another section in front of here, a pre-introduction, this is an introduction to the introduction. Very nice. Let's save and exit, and let's recompile. So now we see that the pre-introduction is the new one, and the introduction is actually number 2. We also notice here that now the table of contents updated, but it only has number 1 introduction, so it's a bit behind. And that is because of how this system works. So LaTeX, when you compile it, it goes through the document, and each section command, it produces some output in some files that is supposed to be used for the table of contents. But the table of contents, it has just been processed, and that was before those files were generated. So one has to run this recompilation step several times when one uses things like table of contents. So if we recompile this again, we will see that it's updated. So one has to run it several times. But there are ways, there are other commands that one can use to do this automatically, that automatically reruns as long as necessary. One such command is LaTeX mk. So let's see if it's installed. It is installed. Very nice. So it automatically runs the system for us. However, this one runs in, it actually ran a different version of LaTeX than we intended. So we'll need to specify that we want it to compile to a PDF. So let's see if we can get it to exit. There we are. So if we want to specify it to run a PDF and we want it to build example .tex, we can specify like this. So let's see, now it has a run through. So it was a bit slow the first time I ran it because it had to set up some things, but now it will be faster. So that is one way to do it. Sometimes you need to install LaTeX mk separately, and sometimes it's included with the distribution. So let's try some of the other sectioning commands before we continue. So let's add a subsection here. So let's put that section into a subsection, and let's run LaTeX mk to recompile it again. So now we see it updated it, and it ran it twice automatically to update the contents, the table of contents. So now we see that we have a subsection which is part of section 2 here. So 2.1 overview, and it's typeset smaller, and it's added to the table of contents in a nice way. So everything is done automatically.